Hello, you are welcome to today's lesson. You can see the topic on the board. Yes, that's the topic. You can see it right. The topic is JAMB 2027, how to solve calculation problems without using a calculator. As you all know, early preparation prevents poor performance. So if you're writing JAMB next year, this is the right time to start. It is not next year to start. You start now. You discover your weak points on time, then you'll be able to overcome them. You work on them on time. Early preparation prevents poor performance. And as you know, in your CBT exam, you will not be allowed to bring in calculator. You'll be restricted to the one on the screen. And in the one on the screen is not very helpful, because there are many functions that will not be there. And apart from that, it slows you down. You locate it, and to maneuver it will slow a fast student down. You need to know how to solve calculation problems without using calculator. This is the main reason for this lesson. Let's prepare now for 2027 JAMB. Are you good to go? Are you good to go? Yes. Good to go, good to go, good to go. So, we are starting from the last to the first. We are turning it upside down. We are beginning from the last one to the first one. So, perfect squares are numbers. And what are those numbers? Any number that can be written in this form is a perfect square. Any number that can be written in the form of n square or s square or y square. If you can square a number, any number written in this form is a perfect square. For example, 1 times 1 can be written as 1, or simply write 1 square. 2 times 2 can be written as what? 4, or simply 2 squared. Give me another one, another perfect square, and it will give you what? 15 times 15 is equal to 225, and it can be written as 15 squared. Give me another one. 16 times 16 is equal to what? 256, or it can be written as 16 squared. So, and so on and so forth. Any number that can be written in this form can be regarded as a perfect square. So 1 is a perfect square, 4 it is, 9, 16. After 16 you have what? After 16 you have 25, right? After 25 you have 36. After 36 you have 49. After 49 you have 64. After 64 you have 81. After 81 you have 100. After 100 you have 121. After 100 you have 121. 121 is 11 times 11. Then you now have 144, 12 times 12. Abi? You have 169. You have 196, right? And you have on and on like that. These numbers, they are called perfect square. Why are they necessary? Okay. Why do we need to know our perfect square? That's the most important. If I know that 9 times, okay, let me use 8. If I know that 8 times 8 is 64, and for example, I don't know 8 times 9, right? I know that 8 in 8 places is 64. 8 in 9 places, what do I simply do? If I know that 8 times 8 is 64, 8 times 9 is what? And I don't know it. What do I need to do? I will simply add 8, because 8 in 8 places is 64. 8 in 9 places, simply add 8. Abi? So if I add 8 to 64, it will give me 8 times 9, which is what? 72. Am I right? 8 plus this, that will be 72. This is the importance of knowing our perfect squares, right? For example, if I know that 12 times 12 is 144, right? And I'm doing a an exam, and I'm doing an exam, that calculator is not allowed, or even though it's allowed, it will not allow me to be fast, right? So what do I do to get from 12 times 12 to 12 times 13? If that is what I need, all I need to do, I know that 12 times 12 is 144. I will simply add 12 to 144 and it will give me 12 times 13. Is it not so? So if I add 12 to this now, I'll just do 6, 5, and what? And what? And 1. So 12 times 13 will give me 156. Is that okay? So we move to the next one. Now, let's go to the second one, type of numbers. It's good to know our type of numbers. So the area I want to approach this one is to talk about our even numbers, prime numbers, and odd numbers. I'm not talking about other type of numbers like integers, like irrational numbers. I'm not talking about them. I'm talking about type of numbers in terms of even, odd, and prime. Even numbers is any number that is divisible by 2 without a remainder. While odd number is a number that if you divide it by 2, it will remain 1. That kind of number is regarded as what? An odd number. A prime number is a number that no number can divide except 1 and itself, right? Meaning a prime number has only 2 factors, 1 and itself. So let's try to write even numbers, odd numbers, and prime numbers from the first 10. Let's write the first 10 on both sides, on all of them. So the first 10 even numbers will be 0, 2, 4, 5, right? 6, 8, 10. How many now? 1, 2, 3, 4, 5, 6. Then we have 12, 14, right? No, let's write first 10. 1, 2, 3, 4, 5, 6, 7, 8. Then we have 16, we have 18. These are first 10, right? It's not so. For odd numbers, the first odd number, I want to emphasize something. What I want to emphasize is that the first even number is 0. It is arguably so. If any number is an even number, if you divide it by 2, it must remain 0, right? So that explains the reason why 0 is the first even number. If 0 is the first even number, then 1 is the first odd number. And just as even number progresses by 2, or even numbers progress by 2, odd numbers also progress by 2. So 1, 3, 5, 7, 9. Am I right? Next one will be what? 11, 13, 15, 17, 19. Right? Even 21, and so on and so forth. These are odd numbers. So if even start from 0, odd start from 1, guess what prime will start from? Prime will start from 2. So the first prime is 2, followed by 3, followed by 5, 7. 9 will not be a prime number because 3 can go in 9, right? So 11 will be the next one, 13 will be the next one, and 15 will not be a prime number because 3 and 5 can go in 15. So from 13 here, we jump to 17. You can write 21. So 19. And 20. You can write 21. You can write 23. And 20 what? 29. These are the first 10 prime numbers. Many students confuse odd and prime numbers. Sometimes they call 15 a prime number just because 2 cannot divide it without remainder. They assume just because 2 cannot divide without remainder, it must be a prime number. A prime number is a number that no number can divide except 1, and it's a. Please consume it very well. Know your odd numbers, your even numbers, your prime number. It will serve you right. Now, the next thing is to know our divisibility rules. How to know when 2 can divide a number, when 3 can divide, 4 can divide, 5 can divide, and so on and so forth. Now, how do we know when 2 can divide a number? Can you give me the rule again? Yes, very good. That is the rule. 2 can divide a number when the last digit is an even number. Yes. We just listed our even number now. 0, 2, 4, 6, 8, am I right? 10. So 2 can divide any number whose last digit is an even number, right? How do we know that 3 can divide a number? 3 can divide a number when we sum all the digits of the number together and the result is divisible by 3. 3 can divide a number when you sum all the digits of the number together and the result is divisible by 3. Let's take this one for example. Many students will not know that 3 can divide this number, but 3 can divide it. How do we know? 1 plus 2 is what? 1 plus 2 is 3. 3 plus 3 is 6. So when we sum this number together, the sum of all the digits is 6. So that means 3 can divide this number. Because when I sum the digits together, the result is divisible by 3. For example now, if I write 51, very few students will know that 3 can divide 51. And it's very easy to know. Just 5 plus 1. And we can just put many numbers together. Like this one now. Like this one. Many students will not know that 3 can divide this number. And it's very easy. 1 plus 1 and so on and so forth. I can add something again. I can add something again like this. If you add them now, how many? 1, 2, 3, 4, 5, 6, 7, 8, 9. 3 can divide it. Okay. So this is how to know when 3 can divide a number. Can 3 divide this number? Yes, because when you add the digit together, the sum is 3. The sum of all the digits is 3, and 3 can divide 3. So this is how to know when 3 can divide a number. When we sum all the digits of the number together, and the result is divisible by 3. So how do we know that 4 can divide a number? The last 2 digits, right? Let's say 4y. So y can be 4, right? Y can be 0 and y can be 8. So let's add anything we like here. Yes, let's add whatever we like here. Now these numbers, 4 can divide them. How do we know? The last 2 digits, look at them. The last 2 digits, right, form a number that 4 can divide. Can 4 divide 44 without remainder? Yes. Can 4 divide 40 without remainder? Yes. Can 4 divide 48 without remainder? Yes. That means 4 can divide all this number without doubt. 4 can divide any of this number. Why? Because the last 2 digits form a number that 4 can divide. This is different from the first rule about 2. No, 2 can divide a number when the last digit is an even number, right? When the last digit is an even number, 2 can divide, am I right? But this one, when the last 2 digits, it's not just the last digit now. The last 2 digits form a number, right? Form a number means that you are not looking at the number as individual, 4 and 4, no. You are looking at the number as a unit. 44, not 4 and 4. 40, not 4 and 0. 48, not 4 and 8. So as a unit together, if the last 2 digits form a number that 4 can divide, that means 4 can divide the number. No matter how long the number is, you can actually add something. If you like, add anything you like. You can add this one. You can add this one. Whatever you add, once the last 2 digits is divisible by 4, 4 can divide the number. No matter what you add anything. It's not very easy. Very interesting, right? 4y. 4y means y can be 4, y can be 0, y can be 8, right? Yes. How do we know that 5 can divide a number when the last digit is 0 or 5? Thank you very much. I almost forgot that. How do you know that 5 can divide a number when the last digit is 0 or 5. When the number ends with 0 or 5, 5 can divide it. How do you know when 6 can divide the number? Tell me. When 2 and 3 can divide the number at the same time. Thank you very much. When 2 and 3 can divide a number at the same time, that means 6 can divide that number. Hello? Let me tell you one that you don't know before. How do you know that 36 can divide the number? How do you know? When 4 and 9 can divide the number at the same time. You know, 4 and 9, if you multiply them together, they give you what? You know, 2 and 3, if you multiply them together, they give you what? 6. So before 6 can divide the number, 2 and 3 must divide that number, right? How do you know that 20 can divide the number? When 4 and 5 can divide the number without a remainder. It's not so. Or when, apart from 4 and 5. Okay, 32, right? How do you know that 32 can divide the number? When 8 and 4 can divide the number, that means 32 can divide the number. How do you know that 72 can divide the number? When 8 and 9, because 8 times 9 is 72. It's not so. When 8 and 9 can divide the number, that means 72 can divide the number. It's not so. So we don't need a calculator to solve problems in mathematics, in physics, in chemistry. With all these fundamentals I'm teaching you, you will be able to smash any calculation exam without having calculator, without having to depend on calculator. You may have it, but you will not depend on it because you want to be fast. You don't want anything that will slow you down. Now we move to we are talking about number 6, right? When 2 and 3 can divide the number at the same time. 7 is problematic for students. Please don't mind the noise of the goat. To know if 7 can go in a number is very easy. Let's see 301. One of the ways to know if 7 can go in a number is to try and see. And one of the ways is to apply a formula. Let's try and see first. 7 can go in 30. It will go 4 times. If we are dividing by 7, it will go 4 times. That is, out of 30, it will go in 28 4 times, remainder 2. And 7 will go in 21 3 times. So, and you can also apply a particular formula, and the formula is this: how to know if 7 can divide the number. You can apply another formula. You remove the last digit. You remove this particular one, the last digit. Then you are left with 30. So this last digit you remove is 1. You multiply it by 5. And when you say 1 times 5, the result is 5. Then you now add the 5 to this 30 that is left behind after you remove 1. You know, you remove 1 from 301, 301. When you remove 1, multiply by 5. This 5 is constant. Whatever the number is, you want to try. This 5 is a constant. You remove the last digit, multiply by 5. And when you get the result here is 5. You add it to the original number that is left behind. So you now say 0 plus 5 is 5. This is 3. The last result now is 35. And 7 can go in 35. Am I right? 5 times. So this is how to know when 7 can divide the number. How do you know when 8 can divide the number without stressing ourselves? To look for other formulas. Once 2 and 4 can divide the number, 8 can divide it. Why? Because 2 times 4 is equal to 8. It's not so. So if 2 and 4 can divide the number, 8 can divide that number. I think it's as simple as that. Let's move forward. For 9, what we do, just like 3, in the case of 3, you will add all the digits together. Am I right? In the case of 9, the same thing. Add all the digits together, the digit of the number. If the sum is divisible by 9, that means 9 can divide the number. Let's say we want to find out if 9 can divide this number. All we simply do is to add all the digits together. If 9 can divide the sum, that means 9 can divide this number. 1 plus 8 is 9. Am I right? 9 plus 9 is what? 18. Is it not so? 20. 20. Oh, it's 27, right? So what we do in the case of 9, add all the digits together. If you add everything now, you have 27. And since 9 can divide 27, that means 9 can divide this number. Is that okay? Then the last one, 10 can divide the number when the number, guess when the number ends with 0. Any number that ends with 0, 10 can divide. So we have known all the rules now. Now we are going to look at factors. What are factors? Factors and multiples. What are factors and multiples? Let's use a simple number to talk about factors. Let's put 10 here, for example. If I put 10 here, let me put 10 here, and let me do something like this. Factors of 10, I'm going to write 1, right? Because 1 can go inside 10. Am I right? 2 can go, and what again? 5 can go, and 10 can go. These are factors of 10. But multiples of 10, they are the number that 10 can go into. Am I right? 10 can go into 10. Then the next one is 20. The next one is 30. The next one is 40. With this, we can differentiate between factors and multiples. So factors of 10 are numbers that can go into 10. Am I right? While multiples of 10 are numbers that 10 can go into. So, and the numbers start from 10 and above, while factors start from 1 till 10. I think we are done with factors and multiples. So, we want to find the HCF of this number. At the same time, we want to find the LCM, lowest common multiple. Now I want to find the HCF of this number. At the same time, I want to find the LCM of the same number. What is going to be the HCF of 1, 2, 4, 8? The highest common factor that can go in all of them will be what? The highest common factor that can go in this is 1. 1 is the only number that can go in all of them. So the highest common factor of this is 1, while the highest common factor is 1. Is that okay? Is that okay? Now let's write another one. Right? Now if you look at this, the highest common factor here will be what? 5. 5 is the highest common factor here. The lowest number that all of them can go into is 20. Now let's do another one. This time around, we're going to work it. Before we work it, we'll try to know it without working it first. Let's call this place 40. Let's call this place 20, and let's call this place 10. So HCF and LCM. Before we work it, let's try to know the HCF and LCM. Right? The HCF here will be what? Looking at it like this, the highest common factor here is going to be what? The highest number that can go into this is 10. Okay? Can any other number go into this again? The highest one. Yeah, I know 5 can go into all of them. Okay, let's say it this way. 1 can go into all of them. But is 1 the highest common factor? No. 2 can go in all of them. Is 2 the highest common factor? No. 5 can go in all of them, but 5 is not. So the highest common factor that can go in all of these is 10. Why the lowest common factor will be what? I say lowest common factor. Why the lowest common multiple? The lowest common multiple will be what? Have I been saying the lowest common factor since? Or I've been saying lowest common multiple? Okay, so the lowest common multiple is going to be 40. LCM, that is the lowest number, that 40, 80. So do you know that all of this can go into 80, abi? It's not so. All of this can go into 120. Am I right? All of this can go into 160. Am I right? All of this can go into 200. And all of them can go into 40. So 40 is the lowest number that all this number can go into. Abi? As the lowest common multiple. All these are multiple of all these numbers, right? But the lowest of them is 40. Is that all right? Now, if with all this explanation is not clear, this is how to work it. Let's say we want to work HCF. HCF, we want to work it. We do line like this. This is 10, right? This is what? 20. And this is what? 40. So we do 10 goes here, 5 goes here, 1, right? So we write 10 equals 2 times 5. Here 2 goes there, how many times? 10. 2 goes here, how many times? 5. Then 5 here, 1. So we write 20 equals 2 times 2 times 5. Here 20 is 20. 20 goes in, 2 goes in 40, 20. 2 goes in 20, 10. 2 goes in 10, 5. 5 goes here, 1. So we write 40 equals 2 times 2 times 2 times 5, right? So we have this one, right? And we have only this one. So only 2 is common to all of them. 2 is here, but 2 is not here again. 2 is here, is here, but it's not here again, right? So, but 5 is in all of them. So we pick 2, the first 2. We can see 2 in each of them. And we can also see only 1 5 in all of them. Only 1 2 in 10, 20, and 40. This 2 does not reach 10. This 2 does not reach 20 and does not reach 10. So only this 2 is common to all, and only this 5 is common to all. So the HCF now, the highest common factor is 10, as you can see here, right? Is it clear now? Now let's say we want to find the LCM. The LCM, we join them together. We call this one 10. We call this one 20. We call this one what? 40. So this is a LCM, lowest common multiple. 2 goes in 10, 5 in 20, 10 in 40, 20. 2 can still go, right? It will go here, but it will remain. So you drop it. 2 goes in 10, 5. 2 goes in 20, 10. 2 can still go in 10. It will go here, but it will remain. You drop it. You drop it. 2 goes in 10, 5. Then 5 go in all of them. 1, 1, 1. So we multiply everything. 2 times 2, 4. 4 times 2, 8. 8 times 5, 40. So LCM is equal to 2 times 2 times 2 times 5, which is equal to 40. So this is how to work the HCF and LCM. You can also know it without having to work it. So it depends on your level of expertise. Square and cube root. Let's use 64 as example. We want to find the square root of 64, and I want to find the square root of the cube root of 64. So remember, we are tackling problem without calculator. Now we want to find the square root and cube root of 64 at the same time. To find the square root of 64 is very easy. All you just do is to behave as if you are solving HCF. Use factor method. Factor method 64. Find the factors of 64, like you do highest common factor that time. So 2 here is 32. 2 here is what? 16. 2 here is what? 8. 2 here is what? 4. 2 in 4, 2. 2 in 2, 1. So since it is square root, we don't normally put 2 in square root. But from 3 and above, we put it. If it is root 4, you put root 4. If it is root 5, you put root 5. So from 3 and above, you put it. But for 2, we don't put anything. So if the square root, you group the number in twos. So this pair is complete. So you put 1, another pair. So you pair the number. So 2 times 2, 4. 2 times 2, 2 times 2, 4. 4 times 2, 8. That means the square root of 64 is equal to 8. So let's find the cube root of 64. If it is a cube root, we don't group it in twos. We group it in threes. If it is cube root we want to find, so the meaning of square root, it means if we multiply 8 by itself, it will give us 64. So square root means a number that you are going to multiply by itself that will give you 64. Now, cube root means what is that number that you multiply like this? If the number is x, for example, it will be x times x times x, and it will give you 64. So what is the value of x? So that number is what we are looking for. A number that will multiply itself 3 times, x times x times a, that will give us 64. So that is the cube root of 64. And it is what? So what you do is to group this number in threes because it is cube root, right? So you group it in threes. Number 1, number 2, 2 times 2, 4. So the cube root of 64 is 4, meaning 4 times 4 times 4 will give you 64. This is a quadratic equation. And let's say we want to find the factors. The first thing we do is to say this one, a times c, 12 s squared multiplied by minus 2, right? So we do 12s squared multiplied by minus 2. And that will give us minus 24s squared. So this minus 24s squared, we share it into 2 factors that will equal minus 5x. So how do we know the factors? 2 numbers, if we multiply them, we have what? Minus 24. But if we add them or subtract them, we have minus 5. So this is how to factorize, how to find the 2 factors for quadratic equation if you are solving it with a factorization method. Okay? If you want to solve it with factorization method, this is how to go about it. Is that okay? To know your 2 factors, this is how to go about it. So you say 1 will go in 24, how many times? It will go how many times? 1 in 24, how many times? Say it now. To go 24, right? 2 will go in 24, how many times? 12, right? 3 will go in 24, how many times? So without wasting time, I have seen my 2 factors because this is minus 5. So if I put minus here, so 3 minus 8, it will give me what? So I've got what I'm looking for. I'm looking for minus 5. And if I put minus here, if I put plus here, plus 3 minus 5, plus 3 minus 8 is going to give me my factor. This is how to find the factors of quadratic equation if you want to solve the problem by using factorization method. Is that okay? Lastly, how to multiply, divide, and even add and subtract decimal numbers. So let's look at decimal numbers. Please remind me of this 100 or this one, the mean base 10 numbers, okay? Now let's first say we want to add and subtract this number. So these 2 numbers, we want to add and subtract them. So how do we write them out? Please tell me, how do we write them? Let's say we want to add them first. Let's say we are adding them first. The first thing we write is what? Okay, this is 0.24. Okay? So 24. How do we add 24? I should put it there. Eh? Can you see yourself? Point nothing. Nothing is there any point here? No point. So you put 20 there because there is no point. So you put your point here, 0. Then you put your 24 here. So when there is no point, you assume it is point something. There is no point, so we put our point here, we write 0, 0. Then your whole number. By now, you should be able to differentiate whole number and decimal number. This 24 is the whole number. It's on the right of decimal point. Sorry, on the what? On the left of decimal point. This is a whole number. So a whole number must be on the left of decimal point. Is that okay? While a decimal number must be on the right of decimal point. Hello? Hello? Please don't forget this. A whole number like this must be on the left of decimal point. While a decimal number like this must be what? On the right of decimal point. Right? And if there is no decimal point, put decimal point there and put 0, 0, right? So 4 plus 0 is 4. 2 plus 0, so 2 here, point 4 and a 2, right? So 24.24. So this is how to add decimal numbers, right? Now, assuming you want to subtract, the order matters. The one you write first matters. Assuming you are subtracting, let's say you are finding the difference of the two numbers. That is, you want to find the subtraction. You want to minus the smaller one from the bigger one. Is it not so? So when you want to minus or find difference, the order in which you write them matters. The one you write first matters. In the case of addition, anyone you write first is okay. So if you want to subtract the smaller one from the bigger one, ask yourself, which one is the bigger one of this? So don't say because this one is 3, this one is bigger. No, this is a smaller number. Why this one is the bigger one? So write 24 first. Put point. This one, after point, you have 2 digits to your right. So you put 20. So point is here, right? Put your point. To your right, you have 24. So put it here. Decimal place. Decimal position. Then the whole number position. Nothing is there. You can put 0, 0. Then you subtract it. So when you are subtracting, please, the bigger number comes first. And the bigger number does not depend on the number of digits. This one is 2. This one is 3. But here, this one is bigger. Please take note. Why? Because this one is a whole number. Why this one is decimal number? This one is not even up to 1. Because it begins with 0. So, to remove 0 minus 4 is not possible. So you borrow from here. Here remain 3. Here, when the one you borrow comes there, become 10. Borrow 1 again, remain 9. The one comes there. 10 minus 4 is 6. 9 minus 2 is 7. 3 is remaining here. 3 minus 0 is 3. Let's not forget our point. 2 minus 0 is 2. So this is going to be the result for what now? For subtraction, for difference, or for minus. Then, if we want to multiply this number, we multiply as if it is whole number. When we finish, we put our decimal point. Let's say we have this number like this. So this is what we have. We want to multiply this number. So what we do is to multiply them as if it is whole number. So we write 241 times 24. We ignore the decimal. Just every decimal, you ignore it. Okay? Okay, let's say there is a 0 here. 0.01. This 0, you will not ignore it. Why? Because it's not starting the number. Like this one now, this 0, you will ignore it. But this one cannot be ignored because it's not beginning the number. Is that clear? So we write this way, 2401. Is that okay? Is that okay? This 0 cannot be ignored. Only this one can be ignored because this one begins the number. So this one, you take it as 24. 24. 24, right? Then you multiply 4 times 1, 4. 4 times 0, 0. 4 times 4, 16, carry 1. 4 times 2 plus 1, 9. So you are done with the first number, right? So you move to the second one. The second one, right? So you are done with the first one, aren't you? You are done with this 4. So asterisk, don't put anything there again. So next number now, 2 times 1, 2. 2 times 0, 0. 2 times 4, 8. 2 times 2, 4. Don't forget to clean this one. So you add. This is 4. This is 2. This is 6. This is 17. This is 5. So this is our, remember the number is not whole number, it's decimal number. So you put decimal back, right? After decimal to your right, how many digits? 1, 2. After decimal to the right, how many digits? 1, 2. So you count 1, 2, 3, 4. Put decimal back. So this is how to multiply, okay? Any number that has decimal number. Is that okay? Let's do another one. Let's say we have this number. Let's say we want to multiply this number. All we just do is to say 5 times what? 54. It's not so. 54. Sorry, 2 times 54. Right? 2 times 4 is 8. 2 times 5 is what? 10. Right? So we have 108. Let's put our decimal back. Right? After decimal to your right, how many digits? 1, 2, 3. After decimal to your right, how many digits? 1, 2. Make it 5. You count 1, 2, 3. It has finished, right? So you make it up with 0. 1, 2, 3, 4, 5. Put your 0. So 0.00108. That's how to multiply decimal number. Is that okay? Now, let's say we want to multiply a decimal number with a base 10 number. This is a base 10 number now. Let's say we have 2, 4, this, right? Multiply by 10. Multiply by 100. Multiply by 1000. This is base 10 number, right? Base 10, right? Base 10 means this is 10 raised to power 1. This is 10 raised to power 2. This is 10 raised to power what? Power 3. So they are base 10 numbers. Is that okay? So if you look at this one, multiply by 10. Move decimal to here. How many times? Move it here. How many times? 10 has 1 0, right? So decimal will come here. Move it one time. It becomes 4.8, right? Here, 100, right? It has 2 0. Am I right? Move it 2 times. 1, 2. So it becomes 448, right? Here is 30, right? So you move it 3 times. 1, 2, nothing again. So you add 0. So this is how to multiply number. Is that okay? How to multiply a decimal number by base 10 number. Let's say we are dividing. We are dividing, right? Assuming we are dividing. We are dividing by base 10 number, right? If we divide this, we are moving decimal to the left. So it will become 4, 8, right? Come here. Is that right? We are moving decimal to the left if we are dividing, right? Here, decimal will move 2 times, Rabbi. 1, 2, right? It will move 2 times. So we write 8, 4, right? 4, 1, 2. Can you see? 0.0 before the 448. Am I right? Here is 0.448. Now here we are moving it how many times? 3 times, right? So we write 8, 4. The first time now, 4. Second, third. So this is how to divide the decimal number by base 10 numbers. Is that okay? Is that okay? Now, let's say we want to divide with non-base 10 number. Let's say we are just as we multiply by non-base 10 number. Let's divide by 10 by non-base 10 number. We are dividing this by 0.2. Let's say we are dividing this by 0.2. All we just do is to change this number to fraction and change this one to fraction at the same time, right? To change this number to fraction, write it as if it's a whole number, right? But write over 1. After your decimal point, how many digits you write? 1, 2, 3, 4. So put 1, 2, 3, 4, right? Divide. You write your 2 over 1. After your decimal point, to your right, how many digits? 1. So you have turned it to fraction. With this, you can just do it. So you have 2, 4, 4, 8 over 10,000, right? It's not so? Yes. Change it to times. 10 goes up, 2 will come down. 0 cancel 0. 2 here 1. 2 here is 1. 2 here is 2. 2 here is 2. 2 here is 4. Over what? 1,000. Have we? If you are dividing by 1,000, it's very easy. How many zeros are you seeing there? So you count 1, 2, 3. Put decimal here. So it become. So you are counting 1, 2, 3. So 1, 2, 3. Put decimal. So this is the final answer. Is that okay? This is how to divide decimal numbers. Is that okay? Now let's say you will notice that I ignore this 0, right? Am I right? This 0 is ignored. But let's say the 0 is here. In that case, we cannot ignore it. We must include the 0. Alright? So it will be like this. Is that okay? We can only ignore the first 0. We cannot ignore the 0 in between. Is that okay? That one is taken care of. So we have done how to multiply decimal number by decimal numbers. How to multiply decimal by base 10 numbers. Abi? How to divide decimal by decimal. And how to divide decimal by base 10 numbers. Am I right? So lastly, let's see look at another one. Let's have a question. Assuming we have a question like this. If we are to solve this number, square root of 1.44, cube root of this, how do we solve it? We must change all this number to whole number to be able to solve it, right? Now let's change that to whole number. It will become like this. 27 over 1. How many 0 are we going to put? For the up one, how many 0? Okay. So I'm going to put 3. 1, 2, 3, right? 1, 2, 3. If you look at this root, it's not just on top of the numerator. It's also on top of the denominator. Am I right? So, but let us separate the denominator now. Okay? Well, we are going to what? Separate the numerator. Sorry. If you look at the cube root, it's not just on top of the 0.027. It's also on top of what? 0.008. Am I right? So the cube root is not just on top of the 0.0027, also on top of the 0.008. So I will share it. I will share this cube root to the two of them, right? So I'm going to have here 8 over 1. How many 0 will I put? 1, 2, 3, right? 1, 2, 3. Just like this one. Right? Then we have what here? We have this one. It's not so. So I'll give me 144, right? Over what? 1. How many 0 will I put? 2, right? So if I do this, we all know how to work our cube root. What number will you multiply by, say, 3 times that will give you 27? 3 here, 9. 3 here, 3. 3 here, 1. So you group it 3 times, Abi, in threes. The number is 3, right? So the cube root of 27 is what? 3. Am I right? Then the cube root of 1000 is what? Is 10. So over 10. It's not so. It's not so. So let's write like this. 3 over 10. Then for this one, here it will be 2, right? Here it will be 2 over 10. Am I right? It's not so. So let's write it this way. Okay? We write 3 over 10 over, right? Over means divide. It's not so. It's not so. Become 2 over 10, right? Then we should not forget this, right? Times square root of 144 is what? 12. Of 10 is what? 10. So we have this. Right? Now let's change it to times. So we have 3 over 10 times 10 over 2. Let's join this one. Times 12 over what? 10. So 10 we cancel 10. Am I right? 12 here, 2 here, 1. 2 here is what? 6. Am I right? 3 times what? 8 is what? 3 times 6. 18. 18 over what? 18 over 10. So final answer is what? 1.8. Count 0 and put your this thing as 1.8. That's the last answer. So you can see how to handle this type of numbers. With this, we have seen how to solve calculation problems without having to use calculator. If this video is helpful to you, please support this channel by subscribing to it and press the notification button. It also gives you another advantage, another opportunity to see any video we release. You'll be one of the first people that will see it if you subscribe and press the notification button. Have a wonderful time. I see you in the next lesson. Bye.